In mathematical physics, today I am going to start a new chapter, which is actually the applications of derivatives. Actually, this is just a lower level physics, you can say, and this course is actually for the students of BSc semester 1 of CBCS system, particularly for all universities of Bihar. So, this is a very important concept, that is application of derivative, because the use of the application of derivative is finds almost in all branches of physics. Okay, and this is a very simple concept. You have definitely studied it in your course on calculus in your +2 level. But as the syllabus of BSc first semester contains this chapter, so I am just starting this chapter for your convenience. The first concept which we will discuss in this application of derivative is geometrical meaning of derivative, or you can say the geometrical meaning of dy by dx. Okay, and for knowing the geometrical meaning of derivative, you have just definitely some preliminary ideas about the differentiation of a function, and I hope you all have an idea of differentiation of a function because you study it in your course on calculus in your +2 level. So let us start to know what is the geometrical meaning of derivative or dy by dx. For this, we consider a curve, as you can see in this figure, which is marked by y equal to f of x, because you know any plane curve is expressed as in terms of y as a function of x. So y equal to f of x, this represents a curve. This is just an arbitrary curve I have assumed. And on this curve, you can see in this figure, I have considered 2 points. First point is P and another point is Q. Okay, and I have supposed that the coordinates of this point P are x and y, and that of Q are x plus delta x and y plus delta y. It means when you move from point P to Q on this curve, then the x coordinate of the point is changed by delta x and the y coordinate is changed by delta y. So you can also say that this delta x and delta y are the change in x and y coordinates. Now, for knowing the geometrical meaning of dy by dx, you have to construct something in this figure, and for this purpose you must draw a perpendicular. Let us see the figure, this PA on x-axis, and another perpendicular, this QB on x-axis, and we also draw a perpendicular PR on this line QB. Okay, so as you have considered that x and y are the coordinates of point P, so in accordance with this figure, you can see this OA will be equal to x. OA is equal to x, and this PA will be equal to y. Okay, now again you can see that this OB will be equal to what? This is x plus delta x, and I have marked this in this figure, and this QB is equal to y plus delta y. So it is evident from this figure that if you want to find the value of this AB will be what? This will be simply OB minus OA, and OB is equal to x plus delta x and OA is x. So this is x plus delta x minus x, and that will be simply equal to delta x. Okay, and similarly you can see, if your aim is to find this QR will be what? This will be QB minus RB. But see the figure, RB is just equal to PA and that is equal to Y. So this will be Y plus delta Y minus Y, and that will be simply equal to delta Y. So I have marked this in this figure, you can see. Okay. Now let us join the point Q to P and proceed it. So after joining this line, after joining the points Q and P and after proceeding it, this line intersect the x-axis at a point C, as you can see in this figure. And this joining line actually makes an angle theta with the positive sense of x-axis. Okay. But as this PR is perpendicular to a line which is parallel to y-axis, so this PR will be parallel to x-axis, and this line QPC intersects these two lines. So from elementary geometry, you know that this angle QPR will be equal to this angle QCX, and so this angle will be also theta. This is just an elementary geometry, you know it. And so from this figure you can see, if your aim is to find this tan theta, what will be this? This tan theta will be QR divided by PR, but QR is delta Y and QPR is delta X, so this is delta Y by delta X. Okay. Now if you consider that this point Q moves towards the point P, okay, then length of this delta Y and this delta X will decrease. And if you consider that Q is almost at this point P, then this delta X will tend towards 0. It means when you say that Q tends to point P, then delta X will tend towards 0. And this chord, this QPC line is the chord of this arc, and this chord will then change into the tangent, this PT. Chord will change into PT. It means QPC line, which is actually a chord, this will change into a tangent PT. Okay. And this tangent makes an angle psi, I have assumed it psi, with the positive sense of x-axis. So you can say that in this limiting condition, this theta will tend towards psi. So when you will actually impose this condition on this equation, then what will be the result? So you can write that this limit theta tends to psi tan theta, this will be equal to limit delta X tends to 0, because when theta tends to psi, then delta X tends to 0. So these are the same limiting condition, and this will be delta Y by delta X. And you know from calculus that actually this limit delta X tends to 0, delta Y by delta X, this is just equal to dy by dx from the definition of derivative or definition of differential coefficient of y with respect to x. And we will substitute psi at the place of theta. So this tan psi will be equal to dy by dx. And this is actually the geometrical meaning of this dy by dx or derivative. As you know that psi is the angle made by this tangent drawn at the point xy or P, and it makes angle psi with the positive sense of x-axis. This angle psi is actually called inclination of this tangent. Okay, and when you take tan of this psi, that is tan psi, that is called slope of this tangent at the point P to the curve. So you can say that dy by dx is simply equal to slope of the curve at the point xy. So dy by dx is equal to slope. This slope is also called gradient. So you can say that dy by dx is equal to slope or gradient. Okay. I think you have understand these facts. But for your convenience, I have clearly written all these things here. You can see. So you can note down in your notebook from my video, and that will be a good notes. Okay. If in your examination it is asked to you that explain the geometrical meaning of dy by dx, you can write down these things. Everything which I have just described has been clearly mentioned here. Okay. So there is no need to repeat these things, and you can note down this by pausing the video. You can note it. Okay. And so you can see I have considered here that when the point q tends towards p, then delta x tends to 0, delta y also tends to 0, and the chord qpc tends towards the tangent pt, and theta tends to psi. So all these things happens due to the point q is tending towards p, and in that condition you have seen that this chord is actually converted into the tangent. Okay. And I have imposed this condition on that equation, and you get that tan psi is equal to dy by dx. This dy by dx is also written like this. This is y dashed or f dashed of x, because y is equal to f of x. So you can write dy by dx equal to f dashed of x. Mark this. Actually, this derivative dy by dx or f dashed of x, that will depend only on x, not on y. So in bracket I have written only x, not x and y. Okay. And this is actually the geometrical meaning of derivative or dy by dx. So dy by dx is equal to tan psi, and tan psi is called what? This is called slope of the tangent drawn at a point x and y. It means the point whose coordinates are x and y. Okay. Now after getting the meaning of this dy by dx geometrically, which is equal to slope of the curve at point x and y, now we will see some of the important facts regarding this geometrical meaning of dy by dx. And all those important points are actually very important for solving the objective problems. In your examination, objective questions are asked, and if you will remember all those facts and understand all those facts, the solution of this objective type question will be very easy to you. Okay. So let us see the important facts, important points regarding this. You can see this curve. Actually, this is also a curve, let us say y equal to f of x. But you can see that the value of this y are maximum at this point p1, p2 and p3. At all these points, this function y has a maximum value. And similarly, at the points q1, q2 shown in this figure, this function has minimum value. Now, if you want to find the slope of this curve at the point P1, P2 and P3, what will be that slope? And for getting the value of slope, you must draw tangents at these points. You know, the tangents at these points, you can see the figure, will be just parallel to x-axis. And if the tangents are parallel to x-axis, what does it mean? It means the inclination of these tangents drawn at the point P1, P2, P3, that will be equal to 0. So these tangents makes 0 angle with x-axis. Okay. And so you can say that tan psi will be equal to 0, because tan 0 is 0. But tan psi is equal to what? This is dy by dx. So slope of this curve at all the points of local maxima is equal to 0. Okay, remember it, that at local maxima the slope of the curve or tangent is equal to 0. Or you can say that this f dash of x is equal to 0 at the point of local maxima. And similarly you can also see that at the point of minima, again the tangents drawn are parallel to x-axis, and as the tangents are parallel to x-axis, again psi will be 0. So at the point of local maxima the slope of the curve is also 0. Okay, so I have written it here. You can see that at the points of local maxima or local minima the tangents are parallel to x-axis, and so psi is 0, and so tan psi will be 0, and tan psi is dy by dx or df by dx, and that will be equal to 0. So you can say that f y dashed or f dashed of x is equal to 0. I think we have understand. Now let us consider another curve. See this figure. I have considered another curve, let us say y equal to fx. Okay, and we select a point P whose coordinates are x and y at this point P. And let us draw a tangent to the curve at this point P. You can see this tangent is actually parallel to y-axis. This is parallel to y-axis. And if it is parallel to y-axis, it will make an angle pi by 2 or 90 degree with the positive sense of x-axis. So you can say that the inclination of this tangent is 90 degree, and if it is 90 degree, what will be the slope? Slope means f dash of x, and that will be equal to tan pi by 2. Tan pi by 2. And this tan pi by 2, you know, this is undefined. So you can say that if the tangent to a curve is parallel to y-axis or perpendicular to x-axis, then the slope of the curve at that very point will be undefined. And I have written this fact here. You can see that the slope of the curve y equal to f of x is undefined, where the tangent to the curve is perpendicular to x-axis or parallel to y-axis. Because at these points psi will be pi by 2, and so tan psi will be infinity. Infinity means undefined. Okay, so these are the two very important points, and this will be very helpful in solving the objective questions based on the geometrical meaning of dy by dx. Everything is okay? I hope you are getting the things. Now we will actually illustrate this concept by taking some simple examples. These examples are only to clarify your concept regarding the application of derivative as geometrical meaning of dy by dx. For this, I have considered first of all a very simple problem. The problem says that find slope of the tangent to a curve y equal to x square at a point 2, 4. It means you have to find slope of this curve at a point whose coordinates are 2 and 4. X coordinate is 2 and y coordinate is 4. Definitely you have studied coordinate geometry, and you know that this equation y equal to x square is equation of a parabola. Although for solving this problem we do not need to know that what is the nature of this curve. But for your knowledge, I am saying that this is just equation of a parabola, because the standard equation of a parabola is what? Y equal to 4ax square. This represents a parabola symmetric about the y-axis. At the constant 4a, at the place of constant 4a, in this problem there is 1. Okay. So for your convenience, I have drawn this curve here. This is actually the curve y equal to x square. Okay, you can see this curve is actually symmetric about the y-axis, and it passes through the origin, that is through the point 0 0, because when you take x equal to 0, you can see this equation, then y is also equal to 0. So this curve will definitely pass through the origin. And for both plus minus value of x, when x is either positive or negative, y is positive, so definitely this curve will lie in the first and second quadrant, as you can see in this figure. Now the question says you have to find slope of the tangent which passes through the point 2 4. Let us say this point P is the point whose coordinates are 2 and 4. So we draw a tangent here, and we consider that this tangent makes an angle psi with x-axis. Then you know that psi is the inclination of this tangent, and slope will be what? Slope will be tan psi. Actually, in general, in mathematics, we denote the slope by the symbol m. So slope at the point xy, which I have denoted by m of xy, that is equal to tan psi. But you have learnt that this tan psi is equal to simply dy by dx. Okay? But y is equal to x square. So when you will differentiate it, you will get 2x. So the slope of this tangent at the point whose coordinates are x and y is equal to 2x. Now you can find slope of this tangent at any point, knowing the value of x for that point. In this problem, we have to find the slope at a point whose x coordinate is equal to 2. So at this point, you can write that slope m at 2 and 4 is equal to what? This will be 2 times 2, because x is equal to 2, and so slope is equal to 4. This problem is just a lollipop. You can say this is just a simple problem. This has been solved here only to clarify your concept. Okay, and I hope after this solution you have definitely an idea how we can find the slope of a tangent to a curve at a given point. Now let us take another problem. This problem says find the points, mark it, find the points on the curve whose equation is y equal to x cube minus 2x square plus x minus 2, where the gradient is 0. See, in this problem, the given condition is what? The condition says that dy by dx is equal to 0. Gradient means slope, and that is equal to dy by dx. So in this problem, you are given that dy by dx is equal to 0. And you have to find what are those points on this curve where slope or gradient will be 0. Okay? So first of all, we will find the slope, and then we will equate it to 0, and then we will find the points by getting the value of x and y coordinates for those points. So let us see how we can solve this problem. You can see that the equation of the curve given in this problem is this: y equal to this much. So first of all, we should write down the equation of the curve. Okay. Now, first of all, you have to find the slope of this curve at any arbitrary point xy. It means we have to find the slope of the curve at a point whose x coordinate is x and y coordinate is y. And you have learnt that this slope, which is denoted by the symbol f dash of x, is equal to dy by dx. And what will be that? When you will differentiate this x cube minus 2x square plus x minus 2, what will be the result? dc of this x cube will be 3x square, and that of minus 2x square will be 4x, and this that of x is equal to 4, and that of 2 is equal to 0. So dy by dx, or the slope of this curve at a point arbitrary point xy is equal to this much. This is 3x square minus 4x plus 1. But according to the condition given in the problem, we have to find those points where slope is 0. So let us put f dash of x equal to 0. This is the given condition. But we have obtained that f dash of x is equal to this much. So write 3x square minus 4x plus 1 equal to 0. Now this is a quadratic equation, as you can see. You can solve this equation to get the value of x by using the formula for quadratic for the roots of quadratic equation. But this is a simple problem, a simple expression, so you can factorize. You can write this expression as 3x square minus 3x minus x plus 1 equal to 0. Now in first two terms, you can take this 3x as a common factor. So this will be 3x times x minus 1. And in the last two terms, let us take minus 1 as a common factor. So this will be minus 1 times x minus 1. And you can write it, what you can write it? This will be 3x minus 1 into x minus 1, and that will be equal to 0. I have written it here. You can see this is 3x minus 1 into x minus 1 equal to 0. And so we can equate both of these factors equal to 0. So 3x minus 1 equal to 0, and so x is equal to 1 by 3. Okay. So one of the points will be that for which x coordinate will be 1 by 3. And another factor is x minus 1. So we will equate x minus 1 equal to 0, and from here we will get x equal to 1. So we have obtained that the 2 points where the slope will be 0, at those points x will be equal to 1 by 3 and x will be equal to 1. But if in your question it is asked that you have to find the point where slope is 0, it means you have to find the coordinates of those points. But till now we have obtained only the x coordinate of those points. But we have also to find what will be the y coordinate of these 2 points where slope is 0. So for getting the value of y, what you will do? You can see if x is known, then y can be easily calculated from the given equation of the curve. So when you will put the values of x in this equation 1, you will get the corresponding value of y. Okay. But x has 2 different values, so we will put those 2 different values in this equation 1, and then we will get the corresponding value of y. So now let us put first value x equal to 1 by 3 in that equation. And you can see the equation was y equal to x cube minus, this was x cube minus 2x square plus x minus 2. But we have obtained that x is equal to 1 by 3. So at the place of x we will now substitute 1 by 3. So this y will be 1 by 3 cube minus 2 times 1 by 3 square plus 1 by 3 minus 2. And after simplification you will get this is minus 50 by 27. Minus 50 by 27. Okay. So the first point where the slope will be 0 is what? At that point, for that point x coordinate is 1 by 3 and y coordinate is minus 50 by 27. Okay. Now again we will find the another point where slope of the given curve is 0, and for that we will again put the value of x in this equation, which is actually equal to 1. So now let us substitute x equal to 1 in this equation, and this will be 1 cube, okay, 1 cube minus 2 into 1 square plus 1 minus 2. And after simplification, your result will be minus 2. So the second point where slope of this curve will be 0 is what? At that point x coordinate is 1 and y coordinate is minus 2. So you can see that actually there are 2 points where the slope of the given curve is 0. The first point is what? The first point is 1 by 3 comma minus 50 by 27. At this point slope will be 0, and the second point is 1 minus 2. Okay, at these 2 points the slope of this given curve is equal to 0. Okay, definitely you have understand, because this is a very simple concept, and you can solve this type of problem from your textbook, and you will get you will see that the solution of problem by you will be very easier, very convenient. Okay, now for clarify your concept, I am taking here the third example. The third example says that find the points on the curve x square over 4 plus y square over 25 equal to 1, at which the tangents are parallel to x-axis and parallel to y-axis. There are 2 conditions in this problem, and at those 2 points we have to find the actually those 2 points where the slope of this given curve where the tangents to of tangent at those points to this given curve is parallel to x-axis and parallel to y-axis. Now this question can be solved very quickly by a simple method, not by the method which we have learned. You can see actually this given equation is equation of an ellipse. Definitely you have an idea of equation of ellipse. This is x square by a square plus y square by b square is equal to 1. This is equation of an ellipse. Here a and b, you know, these are actually the semi axis of the ellipse. Okay, semi minor axis and semi major axis, you can say. So if you will draw this ellipse, and then without any rigorous calculation, without the method developed in this concept, you can solve this problem. Let us see. I have shown the figure of this ellipse whose equation is given in your problem. Actually, this equation is x square by 4, and 4 can be written as 2 square. Okay, and plus y square by 25, that will be written as 5 square, and that is equal to 1. So when you will compare with the standard equation of ellipse, you can see that a is equal to 2 and b is equal to 5. Okay, so let us consider this point P1, and if you will draw a tangent at this point P1, you can see that this tangent is parallel to y-axis, And what are the coordinates of these points? You can see if you will take the origin here, the x coordinate of this point is 2 and y coordinate is 0. And at this point P2, again you can see if we draw a tangent, that will be parallel to the y-axis, And what are the coordinates of this point? The coordinates are minus 2 and 0, because this OP2 will be 2 and OP1 will be also equal to 2. This is actually A. And now consider the point Q1. You can see this figure. When you will draw a tangent at point Q1, this will be parallel to x-axis. And at this point, for this point, what is x coordinate? Since it lies on y-axis, so x coordinate is 0 and y coordinate is 5. Okay, and the tangent drawn at this point q2, again you can see, is parallel to x-axis. And what are the coordinates of this point? The coordinates are 0, -5. So when you say that find the points where the tangent to this curve is parallel to x-axis, so the answer of first part of the problem will be what? The answer will be the points are 0, 5 and 0, -5. At these 2 points the tangents are parallel to x-axis. And in the second part of the problem you have been asked that find the points where the tangents are parallel to y-axis, and you can see these are the points P1 and P2 where the tangents are parallel to y-axis, and these points are 2, 0 and -2, 0. So without going through the actual process of solving this problem, from this figure we can say the answer. So if such type of question will be asked in your examination, without making the rigorous calculation, you can directly write the answer with this concept. But now I am solving this problem by the proper method, proper process, because our aim in this chapter is to learn about the slope of the curve. So what you have learned, just we will apply those ideas for solving this problem. Let us see. You are given that the equation of the curve is what? I have mentioned it here. You can see this is the equation of the given curve. And for getting the slope or the gradient of this curve at a particular point, we have to differentiate it, because you know that slope is equal to dy by dx. Why I am finding slope? Because the condition in the problem is we have to find the point where the tangent is parallel to x-axis. And you know where the tangent is parallel, you have learned that their slope will be 0. And where the tangent is parallel to y-axis, there the slope will be undefined. So you can say that in this question we have to find those points where dy by dx is equal to 0. Okay, and we have also to find those points where dy by dx is equal to infinity. Now the problem is like this, or you can say this second condition can be written as dx by dy is equal to 0, because dx by dy, that will be equal to 1 by infinity, and that 1 by infinity will be 0. So definitely if you want to locate those points, you have to find dy by dx and dx by dy. And for these things you have to differentiate this equation 1 first of all with respect to x. So you can see I have differentiated it with respect to x, and this dc will be 1 by 4 times 2x plus 1 by 25 times 2y into dy by dx. This is just a simple differentiation. And this will be x by 2 plus 2 over 25 y into dy by dx, and that is equal to 0. And so 2 by 25 y dy by dx will be equal to minus x by 2. I have simply bring this first term in RHS. And so from here you can find the value of dy by dx. Dy by dx, which is equivalent to f dash of x, that will be what? That will be 25x over 4y. So this derivative at an arbitrary point xy is equal to what? This is equal to 25x divided by 4y. Now we can solve the first problem. According to the first condition in our problem, we have to locate the points where the tangents drawn to the curve is parallel to x-axis. But you know, when tangent is parallel to x-axis, then it makes an angle 0 with x-axis, and so the slope of the curve at that point is 0. So in this condition you can say that dy by dx is equal to 0. But you have obtained that dy by dx is equal to this much, so we will equate this expression equal to 0. So you can write minus 25x divided by 4y equal to 0, and so this x will be equal to 0. So the first point, so the x coordinate of the point where the tangent is parallel to x-axis is 0. Now we have to find the y coordinate of that point. And how you can find the y coordinate? You have learnt in the previous problem that if your aim is to finding the y coordinate of the point and you know the x coordinate of the point, you have simply put this value of x in the given equation of the curve. And you know the given equation is what? This is x square by 4 plus y square by 25, and this equals 1. But here we will substitute x equal to 0. So this first term will vanish, and only there will be y square by 25. So I have written here, you can see y square by 25 is 1, and so y will be what? This will be plus minus 5. So what are those points where the tangent to the curve is parallel to x-axis? The first point will be 0, 5, because x is 0, x has only one value. And the second point will be 0, minus 5. Now you can see this figure. The points where the tangents are parallel to x-axis are this q1 and q2. And you can see the coordinates of point q1 are 0, 5, and that of q2 is 0, minus 5. Okay. So this actually verifies our previous answer. Now we have to locate all those points where the tangents drawn to this curve is parallel to y-axis. But you know, when the tangent to the curve is parallel to y-axis, then it is perpendicular to x-axis. And if it is perpendicular to x-axis, then psi will be equal to pi by 2. And if psi is pi by 2, what will be the slope? Slope is dy by dx, and that will be infinity. So dy by dx will be infinity, and that's why you can say that dx by dy equal to 0, because this is 1 by infinity. Okay. So now it will be easier for us for solving this part of problem by finding dx by dy. And if your aim is to find dx by dy, you must differentiate this given equation of curve with respect to x. Sorry, with respect to y, not with respect to x. So now let us differentiate it with respect to y. So when you will differentiate this first term, this will be 2x by 4 into dx by dy. Okay, dx by dy, and plus dc of y square with respect to y, that will be 2y. So this will be 2y by 25, and that will be equal to 0 because 1 is constant. So you can see I have written here that this yes, this will cancel. This is x by, sorry, dx by dy, and dx by dy, this is, yes, this is x into dx by dy, and this will be equal to what? This will be 2y by minus 2y by 25. Okay, So dx by dy dx by dy, this will be equal to minus 2y by 25x, but dx by dy is 0, so you can say that minus 2y by 25x, which I have written here directly, is equal to 0. And so you can see that this y is equal to 0. So the point where the tangents are parallel to the y-axis, at those points the y coordinates are actually 0. Now for getting the value of x coordinate of those points, what we will do? We will substitute the value of this y in the given equation of the curve. And given equation is what? This is x square by 4 plus y square by 25 equal to 1. Now put y equal to 0. So when this second, we will put y equal to 0, second term will vanish, and this x square by 4 will be equal to 1, and therefore x will be equal to plus minus 2. X equal to plus minus 2. So you can see there will be 2 points. For first point x will be plus 2, and for second point x will be minus 2, and y for both of those points will be 0. So the 2 points where the tangent to the curve are actually parallel to y-axis are what? That will be 2, 0 and minus 2, 0. Okay, and you can see this figure. From this figure you can see at point P1, whose coordinates I have found earlier are 2, 0, and the point P2, whose coordinates are minus 2, 0. Actually at these 2 points the tangents are parallel to the y-axis. So I hope you have understand all these things very clearly. This was a very simple concept, but for a student of BSc first semester it is very important. Okay, thank you very much.